Good afternoon, everyone. Hello, my name is Steve Petrell, and I'm the Associate Dean for Research here in the College of Arts and Sciences, and I'm also a professor of psychology. We are very grateful for your presence here today at this November installment of Science Sundays, which is sponsored by the College of Arts and Sciences, and today is being sponsored by the Center for Cognitive and Behavioral Brain Imaging. Just a little bit of housekeeping before we begin. Following our presentation today, we're going to have a reception, time for questions, then a reception over at the Ohio Staters Traditions Room, which is just around the corner. Actually, it's upstairs and around the corner. I'd like to introduce, so we get right to the point for today, I'd like to introduce Dr. Cian Beilock, who is currently the Executive Vice Provost and the Stella Rowley Professor in the Department of Psychology, and is also the Committee on Education at the University of Chicago. She received her bachelor's degree from UC San Diego and her advanced degrees from Michigan State University, where she holds a PhD both in psychology and in kinesiology. Prior to joining the faculty at the University of Chicago in 2005, she was on the faculty at Miami of Ohio. Her work is both voluminous and varied. She's been very well funded, including a National Science Foundation Career Award. And her areas of study include individual differences in executive functioning, the interaction of emotion and cognition, math anxiety, test anxiety, stereotype threat, numerical cognition, learning in math and science, and performance under stress. And today she's going to talk to us about how to perform your best under stress and take us on a tour of brain science and behavioral science, looking at how we perform best under our most stressful conditions. And with that, I'd like to welcome Dr. Cian Beilock.
Thank you. Thank you, and thank you for coming out today. Let's just make sure I can get my slides up here. We good? Yeah, I think that's going to work. So it's really my pleasure to be here. I attempted to come about a year ago to give this same sort of talk. Is it echoing, or is this just... This mic is on. You're trying to turn it off. And I came down with a sudden case of food poisoning, so I didn't make it. So it's now, I'm happy that I made it this year, and hopefully I'll make up for the absence from last year. So I'm a cognitive scientist, which means I try and understand what happens in the brain and body to help us perform at our best. And I'm not only interested in why we perform at our best, but I'm also interested in what happens when we don't perform up to our potential. So today, I'm going to give you a little bit of knowledge about how the mind works. And the goal is that you can use that knowledge to be better performers in whatever you do, and also help those people who perform around you, whether it's kids or people you work with. And I'm also going to take you on somewhat of a whirlwind tour behind what happens when we have prepared, when we have a lot of knowledge, when we are ready to put our best foot forward, and sometimes we just can't. People often ask me if, in studying this phenomenon, which I talk about as choking under pressure, and I don't here mean performance ups and downs, we all have those. What I mean is worse performance than expected, given what you know, given your skill level, precisely because you perceive the situation to be stressful. People often ask me why I got into this, and the answer I give them is that yes, I do a little bit of me-search in addition to research. I played soccer in the Olympic development program growing up. I had one of my worst performances in front of the Olympic coach watching me. I always wanted to perform the best when I was taking tests, and sometimes I was able to, and sometimes I wasn't. And so I've really developed and built a career on trying to understand what goes wrong in high-stress situations and how we can use that knowledge actually to develop some pretty simple psychological tools and techniques to help everyone perform their best when it matters most, whether we're on the playing field, on the putting green, in the boardroom, or in the classroom. So today I'm really going to ask a question, pose a question about why we choke under pressure, what goes wrong, and what we can do to help ensure success when it matters most. And one thing that we've learned in our research and the research of our colleagues is that a lot comes down to what's happening in our brain in these stressful situations. And often it comes down to this front part of our brain, our frontal cortex that sits over our eyes. Our front part of our brain is essentially much bigger than even our closest primate relative. And it takes up more neural real estate. It takes up more of the brain. And that front part of the brain, that frontal cortex, is so important in helping us focus on what we want and focus and get rid of what we don't. And in high stress situations, one thing that my research has shown is that this frontal cortex goes awry in a way, and we actually focus too much on the details of performance, and we mess ourselves up. That's sort of surprising, right? You hear coaches on the sidelines in high pressure situations yelling at their players, concentrate, concentrate. But my research has actually shown that's one of the worst things that you can do, especially when you're performing something that you know very well. Oftentimes we start thinking too much about the details and we actually disrupt our performance. And I think some of the best evidence of this comes from athletic tasks. So this is one of my favorite all-time examples of choking. This is Jean Van de Velde. He was going to be the first Frenchman to win the '99 British Open. Van de Velde is now translated as French for choke. So this is actually the picture of him in one of maybe the most epic chokes of all sports history. Van der Velde got to the 18th hole. He was 3 strokes ahead. He got up, his first shot ended up in the woods. The second hit the grandstand. The third shot ended up in the water. And this is the picture that was on every sports page the next day. He actually took off his socks and shoes, went into the water, and was thinking about whether he was going to try and hit the ball out of the water. He wisened up, he took a penalty, he ended up in a playoff and lost. It was just an epic situation. And from a scientific perspective, I asked the question, and I've asked the question, in situations like this, what happens? How do people perform differently that leads to this poorer performance? And one thing we've shown is that in these stressful situations, if you actually look at the tapes of Van de Velde, he sat over his shot. He took markedly longer than he'd had in other situations. We've actually brought professional golfers into our lab. I have a putting green as one of my lab pieces of equipment. And we've watched what happens when they crumble under stress. And one thing we show is that oftentimes they start paying too much attention to the details. We want to perform really well, and because of that, we try and control and monitoring everything that we're doing, and that can actually disrupt our performance. It's like if you were shuffling down the stairs and I asked you to think about what you were doing with your knee, there's a good chance you'd fall on your face. It's just not something you think about, and it's best left outside of conscious awareness on autopilot in the moment. It's as if you raise your hand to ask a question or to say something at a meeting, and all of a sudden you start thinking about the words coming out of your mouth, and you stutter, or you disrupt your performance. This is what tends to happen in these stressful situations, especially when we're performing well-learned athletic tasks. So what do you do about this? When you are in these stressful situations and you start realizing that you're worrying about the situation and its consequences, you start paying too much attention, we've actually shown that there's a couple things we can do to enhance performance. One is to have a key word or swing thought in the golf situation, something that takes your mind off the details of what you're doing. Another is to focus on the outcome, what you want to achieve, rather than the steps in the moment. Even something as simple as singing a song can take your mind off of those little details of what you're doing. All of these things we've shown to actually enhance performance under stress. And of course, if you're on the back nine with your buddy and you want to mess them up, you just say, "That was a wonderful shot. What were you doing with your elbow?" So we know in these stressful situations that our frontal cortex goes awry. We start oftentimes worrying about the situation and its consequences. This causes us to pay too much attention to the details of what we're doing, and this can disrupt performance. But these worries in themselves can also be a big problem. My mom used to talk about them as the what ifs. Don't do the what ifs. What if this happened? What if that happens? And we've been really interested in how just worrying about a situation, about its outcome, can disrupt our ability to focus and perform at our best. And we know oftentimes that we worry in the moment, But we also, I think, have all experienced those worries before a stressful situation. And so in my lab, we've actually asked questions about what happens in the brain when people start going into a stressful situation that they are worried about, and whether or not we can see evidence, essentially, of these worries disrupting our ability to focus on what we're doing. Now, we haven't been able to put people playing golf in the brain scanner, an MRI, because one thing, it's just a big magnet, and so the club will go right into the middle. Another thing, unfortunately, is right now we can only actually peek under the hood while people are lying on their backs pretty still. At least that's all we can do at our university. So we've looked at different types of tasks where people get stressed out, not just playing golf, but also another task that tends to be very stressful for a lot of Americans, and that's doing math. So it's an unfortunate situation, but it tends to be the case that you don't hear people, very intelligent people, walking around bragging that they're not good readers, but you certainly hear intelligent people in America bragging that they're not good at math. It's something that Americans fear a lot, and I can give a whole other talk about why that's the case, and I'll maybe tell you a little bit about that. But for our purposes, it's a great task to ask questions about what happens in the brain when people are freaked out about performing. So in some of the work we've done, we've actually invited people to our lab to have their brains scanned, to look at what's happening under the hood, so to speak, while they're doing math tasks. And we've not even been so much interested in what happens during the math task itself, but what the brain looks like when they're just worrying about doing math. So of course, if we're looking for people who are anxious or worried about math, we can't invite them to be part of a study about math or they'll never show up. So we invite them down to our lab to be part of a study on cognitive task performance, and they come in, and we tell them we're going to be putting them in an MRI machine looking something like this, and that we're going to be asking them to do some tasks while they do it. So an MRI machine is really just a big magnet. It's 50 to 100,000 times stronger than the Earth's magnetic field. And all it does is measure the magnetic properties of whatever is inside it. In this case, our brain. So we wheel people in, they're lying on their back. They usually have goggles with a computer screen reflected in them, or they have a computer screen in front of them so they can see it, and they might have a little button box next to them where they can respond to, say, math questions that are put on the screen. We brought people to our lab. We knew some of them were really anxious about doing math and some of them weren't. And when they got here, we said, surprise, you're going to go in this machine. You won't be able to move. You're going to have to do some math. No one ran away screaming. We put them in. And then essentially we asked them to respond to doing different kinds of pretty algebra questions and reading questions. And we were interested in what was happening in the brain when they were doing the math. But what we were especially interested in is what happened in the brain when they were just told they were about to do math. So they would see a little blue square flash on the screen and they knew a math problem was about to come, or they'd see a yellow square flash on the screen and they knew a word problem was going to come. And what we wanted to know was how the brains of people who profess to be really anxious about math look different than people who didn't right before they did the math task. Could we see evidence that these individuals are having negative reactions to something that's about to happen? And if so, could this help us understand what we could do to ensure that in the moment people were able to focus and perform at their best? So as I said, this MRI is essentially a big magnet, and because different types of brain tissues have different magnetic properties, we can get a nice picture of the structure, just what the brain looks like. But with a slight tweak in the technology called functional MRI, we can not only get a picture of brain structure, but we can actually start to infer brain function, how the brain is actually working somewhat in real time. It's a little slow, but we get there. And essentially, the reason we're able to do this is because brain cells are neurons. When they're active, they need things. They need glucose, they need oxygen. And the way that they get those nutrients is through the blood. And when the blood is shunting those nutrients to different parts of the brain, the blood has different magnetic properties, and we can pick that up with an MRI machine and essentially infer which areas of the brain are working the hardest at a particular point in time. So we have people lying in this big magnet, they're doing some sort of task, and we can start to make inferences about differences between groups of people in terms of which areas of the brain are most active. And so we did this. We brought high and low math anxious individuals to our lab. We put them in the scanner. And again, what we're really interested in is what's happening in the brain. What are the differences between people who are really worried about doing math when they know it's coming, not even when they're doing the task, when they know it's coming, versus people who aren't. So these are Science Sunday talks, and I know you guys are a really great audience already. So I'm going to actually show you some pictures of the brain, what we found when we looked at differences between these people who are really anxious versus not. And it's actually pretty interesting. So these are two slices of brain, essentially depicting the differences we found. If you look at the top one, this is, and pretend it's my brain, you've essentially just taken the left hemisphere off, and you're looking in at a slice in an area that's called the mid-cingulate cortex. And at the bottom, if this is my brain, you're standing behind me, you're the doctor looking over, and you've sliced off the top of my head, and you're looking down on both sides bilaterally at an area called the posterior insula. What we showed is that when people were really anxious about math and they just knew it was coming, they hadn't even done any math, these areas of the brain were really active compared to people who liked math. Why do we care about these areas? It turns out the insula and the cingulate cortex are part of our neural alarm system, our neural pain matrix. These are areas of the brain that actually are active when we prick our finger with a needle or stub our toe. And what we were showing is that people who were stressed out about this situation, their brains actually looked, in a sense, similar to what they might look like when they were in physical pain. So when people say math is painful, their brains might be actually showing that. But the most interesting thing is that these neural alarm signals, when they went off, essentially disrupted people's ability to use their frontal cortex to focus during that math task. People started worrying a lot before they even got into the situation, and then they weren't able to focus on what they needed to perform at their best. So this tells us something really interesting. In these stressful situations, even before they happen, we start worrying, and that can derail us, which means we need to think about what we're doing before we get in there. And as we saw from our golfers, when we get in there, we often start focusing on the wrong details of performance and disrupt what we do. So before I tell you about what we can do to ensure we perform our best under stress, I thought today I'd take a little detour and talk about why math tends to be so stressful for us to begin with. So it's definitely the case that some people are really worried and frustrated about doing math, and we've been particularly really interested in that as why that happens in the US especially. It turns out that people all over the world are anxious about doing math, but it turns out that it's particularly heightened in our culture. So why might that be the case? One thing that we've been really interested in is where some of these anxieties or stresses might come from in the future, or in the first place. And one place that we actually looked was early in schooling, after kids had had a first year of school. And one question that we had was where students are learning that math might be something to be afraid of. It turns out it's somewhat prolific across our society. So this was a t-shirt that was actually sold at Urban Outfitters a couple of years ago. But it turns out it comes from lots of other places as well. So there's studies called meta-analyses that take lots of studies and put them together. And there's been several looking at who has the highest prevalence of anxiety or fearfulness about math if you look at all college majors. Does anyone want to guess? It depends on who I'm talking to. I hear psychology, English. It turns out people majoring in elementary education have the highest level of fear about math. There's also something else that's really interesting about people majoring in elementary education, something that makes them really homogeneous. Does anyone know what it is? In the US, our first grade teachers are over 90% women. So my lab has actually asked whether or not a teacher's math anxiety might actually affect what her children, her kids in her class learn across the school year, and whether that could relate to being more fearful about math. And especially given that these are all a majority women, whether or not that could have more of an impact from, say, the girls in their classroom versus the boys. So we've actually done studies where we've looked across the school year. We measure girls and boys math achievement at the beginning of the year, and we also measure girls and boys math achievement at the end of the year. This is across first grade classrooms. And we've asked whether or not that achievement changes as a function of how anxious their teacher is about doing math. I thought I'd take a detour and show you the results of one of our studies that really exemplifies this effect that kids who are in classrooms with teachers who are really anxious about doing math learn less math across the school year, even if you control for the amount of math knowledge that teacher has. And it turns out that these are all females for the most part, and the girls are being affected more than the boys. So here's actually a graph we've collected from over 700 students across the Chicago area. And on this vertical axis, essentially it's just the grade change across the school year. So you can see about 0.9 would be you learn 1 year of school. And what you can see is the blue bars are the kids with the teachers who are lower in math anxiety, who are less math anxious, and the red bars are the kids in classrooms with teachers who are high in math anxiety. And what you see on the left are the girls in the classrooms, and on the right are the boys. So overall, you notice that kids in classrooms with the light blue teachers are learning more math, but you notice how it's affecting the girls more so than the boys. So one way we think that students start developing these anxieties and in turn poor math performance and so on is the fear that their teachers sometimes bring into the classroom. And we've actually looked at whether or not having these math anxious teachers, why it might be so problematic for the girls in terms of math achievement, as to whether or not it actually changes whether girls think that girls should be good at math. So in this study, we actually not only tested how proficient kids were at math, but we asked the girls and boys to draw a picture of a kid who was good at math and a kid who was good at reading. And what we showed is that when girls were in classrooms with teachers who were really math anxious, they were more likely to draw stereotypical drawings by the end of the year. A girl is being good at reading and a boy is being good at math. And here's an example of one of the drawings. So we often had to ask the kids what they were, which the gender was. This is the one on the right was pretty obvious it was a girl. The one on the left we had to ask about, or sorry, the one on the right we had to ask what the egghead was, and the girl would bring us through it. But what we've shown is that when kids are in these classrooms with teachers who tend to be anxious about math, who tend to be mostly female, that by the end of the school year, both boys and girls are performing more poorly. Girls are affected more so than boys, and girls tend to change their idea of who's good at math. So then when we're asking why people are choking under pressure when they're doing math or what's happening in the brain, we can also get an idea of where it comes from in the first place. So I've given you a little tour now of some of the things that happen in these stressful situations. We know we start worrying. We can actually see evidence of these derailed neural resources, these worries, before someone even gets to a task. We know oftentimes we overattend to the details. We don't focus on the right things, and this can disrupt our performance. And with respect to math, we know oftentimes this starts really early. It starts from the teachers in school. What do we do about these stressful situations, though? Once we know that we're worried or we might not perform well, how do we, in a sense, ensure that we're going to perform at our best? So I'd like to take the last half of the talk and actually tell you about some tools that we've developed and that our colleagues have developed, really designed to take some of the science and help ensure that we can perform our best when it matters most. So I showed you how these students getting ready to do math who are really fearful about math, we actually saw evidence of these neural alarm signals going off when they were about ready to perform the math task. There's been actual research done looking at how we get rid of these signals, how we tamp down these signals so that when we're ready to perform, we can focus on what matters most. And some of my favorite research of this comes from athletics. There's been some amazing work done with swimmers. The Canadian Olympic team, in fact, has been really interested in the psychology of sport for a long time and has asked questions about how to take these neural alarm signals that come up in these stressful situations and quiet them down. How to ensure that when athletes perform poorly or are worried about a situation, that they're able to focus on what's important and perform at their best. I actually have been to several Team Canada Olympic meetings, and when I was going to one of my colleagues said, "Go and tell them the wrong thing." And I said, "Science has no boundaries. I can't do that." But Team Canada's been really interesting because they've been very much interested in this psychology of performance. And they did really an amazing study that I want to tell you about with their swimmers. They took Canadian Olympic swimmers who choked, and by this it's pretty easy to tell in swimming, they swam worse in terms of their times than one would expect given their practice, who choked at either the Olympics or the Olympic trials. And they did something kind of mean to them. They put them in an MRI and actually made them watch videos of their failed races. They're tough, it's in the name of science. So what they were interested in, what was happening in the brains when these swimmers were watching these videos, and sure enough, they showed a lot of the same activations that we showed in our students who were afraid to do math. These neural alarm signals were very active. Areas like the insula, the amygdala, the cingulate cortex were active when they watched themselves failing relative to when they watched videos of themselves succeeding. And then they did something really interesting. They trained them to think differently about their failure. Rather than focusing on how they lost for their country or their entire life had been thrown away for what they did, they trained them to think about what happened in non-emotional terms and focus on one thing they were going to change for the future. That's it. Every time this came up, think about what happened in non-emotional terms and what are you going to change in the future. They had them practice this over a 2-week period, some of the swimmers, and some of them did not. They put them back in the MRI machine, and they showed that those swimmers who'd practiced this reframing how they thought of the negative situation actually showed less negative reactions to the videos of themselves failing. Team Canada thinks this is the first step to ensuring that swimmers are able to focus on what they want when it matters most, and they pull their swimmers now poolside. If they've had a bad race, they have them think about what they did in non-emotional terms and focus on what they're going to change for the future. The idea is that when we have these worries, when we start thinking about what might go wrong, it actually changes how we're able to devote and deploy attention to what we're doing. And if we can nip it in the bud, so to speak, if we can focus on just one thing we might be able to control, what we're going to change in the future, it enables that sort of cycle of ruminations, these neural alarm signals, to be less likely to pop up and derail our performance. So what else can we do to ensure that we can perform our best when it matters most? In addition to focusing on that one thing we might change, it's also true that we can take a step back in a stressful situation or even before it happens and ensure that we're able to devote as much of our resources as we need to the situation. One thing that we've actually shown is that when students, for example, are taking a test and they get stuck on a problem, one really great thing to do is to take a step back, go to a different problem and come back. It's almost as if when your computer essentially crashes and you reboot, you got rid of all the dead ends and you're able to maybe see a new direction or way to do something. Psychologists often talk about this as an incubation effect. Just this ability of stepping back, stepping away, and then coming back can be really beneficial. Oftentimes you don't have the chance to do that. Even when you're giving a talk, and that tends to be something that stresses people out, getting a chance to take a sip of water can be a great way to step back and come back to what you're doing. It's also the case that being able to actually step back from what you're doing by going and being in nature can be beneficial. This idea that our ability to focus, to think about and buckle down on what we're doing, it wears out over time. And this ability to step back and come to what we're doing can be really beneficial. Okay, so I've talked now about this idea that in these stressful situations, we start worrying about the situation and its consequences. This often causes us to pay too much attention to the details of what we're doing. These worries, in essence, can derail our frontal cortex, our ability to focus on what we need to and get rid of what we don't. Little things can make big differences. We know that actually, rather than dwelling on the failure, thinking about one thing we might change, being able to take a step back can also be really beneficial. We've also shown that getting used to the kinds of stressful situations that you're going to perform in can be really beneficial. So, for example, we often practice. We practice what we're doing, but we don't practice under the kinds of conditions we're actually going to have to perform in. This is true when we have to give a talk in front of someone else, or when we're taking a test, or in an athletic event. Actually getting used to what we're going to do in the high stress situation can be really beneficial. One of my favorite examples of this comes again from the sporting world. This is Coach Roger Reed. He used to be the head basketball coach at Southern Utah University. When he got there, his basketball team was shooting 265th in NC2A free throw success. That's not very good. Free throws are really great because they're a nice example of where we think the psychology of performance gets in the way of people performing up to their potential. It turns out in the NC2A and in the NBA and the WNBA, the average free throw success is in the 60%. Compared to the kinds of shots that basketball players have to take, there's no reason this shot should be performed so poorly. And one of the reasons we think this is the case is because it's a stressful situation oftentimes when you're up there, and players don't practice under the kinds of conditions they're going to have to perform under. And this, we think, was really true of Coach Roger Reed. When he got there, his team would just practice free throws at the end of practice or on their own, and he essentially changed how they practice them. Instead of having them do it without any stress, in the middle of a scrimmage in practice, he would blow his whistle, he'd bring a guy to the line, he'd have to shoot a free throw. If that guy missed, the rest of his team had to run laps. It's not so fun to go to the locker room at the end when your team has had to run laps. It's a little bit of pressure, and in just a couple years, Coach Reed took his team from 265th in free throw success to the top 5 or 10. This idea of practicing under the kinds of conditions you're going to perform under is really important. It inoculates you in a way to what you're going to have to actually see. Students can do this by actually closing their book when they're studying and testing themselves. We often think that we know the material when it's open and right there, but do we actually know it really well? And can we close the book and create a practice test or test ourselves under the kinds of conditions we're going to have to perform under? This is why people pay thousands of dollars to take test prep courses. Sure, they teach us tricks of the trade, but what they do more than anything is give students practicing taking tons and tons of timed tests next to the people they're going to be competing against. We can do this when we're getting ready to give a toast at a wedding or a talk. Do it in front of someone else. It gets you used to the kinds of physiological reactions you'll have. It also gets you used to having to pull things out on the fly. If no one wants to listen to you, do it in front of a mirror. Put a video camera on you. Anything that gets you used to the kind of situation you're going to perform under will enable you to perform better when it matters most. If you actually walk by your football stadium on a Friday afternoon, my guess is the music is blaring as the guys are getting ready for these big games. They're getting used to the kinds of crowds and situations they're going to experience when it really matters. And the idea is to match how you're practicing as much as possible with how you're going to perform. Okay, so I've talked to you about several techniques now for performing better under stress, whether it's rethinking your poor performances and focusing on essentially one thing you might change, whether it's taking a step back, whether it's practicing under the conditions you're going to perform under. Another technique that I think is a really interesting one has to do with essentially how you hold yourself and your body. It turns out that our bodies matter in terms of how we present ourselves to other people and also how we think ourselves. Oftentimes people think that our emotions are only shown on our face, but actually our bodies tell a pretty good job of what we're thinking, how we're feeling. And if you don't believe me, which you may not right now, I thought I'd show you some pictures of tennis players winning and losing Wimbledon. It turns out, and I guarantee this, you will not be able to predict with any accuracy, nor will you agree on which are pictures of players winning versus losing points. Okay, so we have to do it because you don't believe me. So number 1, win or loss? Loss. Number 2, win or loss? Win. Number 3, win or loss? Win. Number 4, lost. So you guys are not agreeing. I just want you to know that. Number 5, win or lost? Win. Number 6, win or lost? Lost. Now I want you to look in juxtaposition to pictures of players' bodies, and you'll see how much easier it is to tell whether they've won or lost. Top one, won or lost? Bottom one, lost. Our bodies often tell a story. They send a signal to other people, and it turns out they also are powerful for sending signals to ourselves. How we hold our body can actually make us feel more powerful in certain ways. The jury's still out whether it actually does it more than that, but it can change how we're feeling and thinking in particular situations. And our bodies tell a story to other people as well as ourselves. So there's lots of things that we can do in stressful situations and even before to ensure that we're performing our best. Whether it's making sure that we're not dwelling on the negative aspects of a bad performance and really thinking about what we might do differently the next time to essentially tamp down those neural alarm signals. Whether it's practicing under the kinds of conditions we're going to perform under. Whether it's taking a step back in that stressful situation to make sure we can reboot. And also how we hold ourselves can be a big and important factor. I thought I would tell you about a couple more techniques that are really, we think, very beneficial in these stressful situations. And one is something that we've been looking at in our lab and really came from this idea that in order to understand and help people perform best when it matters most, we have to really get a handle on the science behind what's happening. And it came from some of the work we did where we showed that in these students who were really anxious about doing math, when even before the math task happened, those neural alarm signals were going off. We thought, what could we do to help tamper down those neural alarm signals? Well, Team Canada has a technique to get students to think differently about what's going on. What else could we do if you don't have a sports psychologist next to you in the moment to ensure that you can perform successfully? So my students and I went through the literature and we thought, where do we see lots of evidence of worries and rumination? And one place we ended up on was work done in clinical psychology with depressive patients. So it turns out that people who present with depressive disorders ruminate. They tend to ruminate in a way that can be really fixating. And one technique that's been used to help people curtail those ruminations is journaling. Getting those negative thoughts down on paper. It turns out that when people who present with these depressive symptoms journal, they have less doctor's visits, they report being more positive, and we thought, could we use some of this same technique to help people when they're really about to go into a stressful situation, to help tamp down some of those neural alarm signals and help people perform better? And so we decided to test it. We went into a high school while students were freshmen and taking the first final exam of their high school career. And we actually randomly assigned half of the students to a journaling exercise to write about their thoughts and feelings in the moment, and the other half just wrote about something they did the day before. And our question was, could this journaling exercise help maybe download some of those worries from mind so people weren't ruminating, they weren't focusing on them? It was a different way to take what the Canadian swimmers had done and help students just jot down their worries, put them off their plate, so to speak, and allow them to focus and perform their best. We did several lab studies and then went into the high school, and what we found is that for students who tended to worry the most about taking tests, doing this journaling exercise actually boosted their final exam grade from a B- to almost a B+, just from getting their thoughts down on paper. We've since replicated this with people who are anxious about math. It's been shown before students take the LSAT or the GRE. Just this act of getting your thoughts down on paper frees up essentially your focus, so when you go in there you can do and perform at your best. And I thought I'd show you one of the sample writings that one of the students did in this study, just to give you an idea of how this journaling might actually work. So this is what one student wrote. She wrote, "When I first think about this upcoming final, I feel really stressed. I'm worried that it will be on everything I don't know very well and that I haven't prepared enough. This really stresses me out because I'm always worried about grades. I really like doing well, and when I don't do so well, it upsets me. She says, I also have really high standards, and as I continue to think about the final, I relax. I realize it's only a test. I realize I've studied enough. What I don't know, I don't know. I think I know everything I need to. I don't have to worry as much. It's only one test. It won't affect my life drastically. So now I'm okay in terms of stress. I don't have to worry as much. It's not as stressful now. I know I will do well. Great, even, she says. I know this stuff. I've learned what my teacher taught me. I don't have to worry. There's still an undertone of stress. I'm a little bit worried, but everything will be okay. And we actually analyzed students' writings, and we showed that those students who got their worries down and then actually gained a little bit of insight, who realized maybe it wasn't that stressful of a situation. It's kind of like when you write that really angry email that you're not going to send, but you write it and you feel better and you gain a little bit of insight. We showed that those students actually performed the best on the test. And so for students who tend to worry in these stressful situations, something as simple as getting your thoughts down on paper can be really advantageous. We're excited about this technique. We've also actually done similar exercises where in addition to getting students to write about their worries, we've actually talked to them about some of the physiological experiences they might be having, whether it's a sweaty palms or a beating heart. So it turns out that if you give a high school student, a piece of paper saying, we know, this is an important test and your heart might be beating and your palms might be sweaty, you're probably stressed, good luck. That's not so good. But instead, if you talk to them about the fact that these sorts of physiological responses are vital parts of being able to think, perform at your best, helping shunt blood to the brain and all the things that you need to do to focus, those same responses get reinterpreted in a different way and students actually perform better. So again, it's this idea about being able to offload those negative alarm signals, being able to offload in a way those worries so that you are able to focus on what you want to and get rid of what you don't. And really, some of the reasons we've been able to come to these pretty simple techniques is because we've taken a real deep dive inside the science behind why we perform poorly under pressure. Only by understanding that it's oftentimes before a stressful event that a lot of the negative ramifications of these situations come to pass, have we honed in on things like changing our mindset, what we focus on in the moment, journaling, reappraising how we're feeling, and also practicing under these stressful situations. And the moral of the story is that it's not just what we know. Our knowledge, how we prepare in terms of our skills are really important, but our anxieties, our attitudes, and our mindset is just as important. And if we're really going to perform our best in stressful situations, not only do we have to practice the actual tasks that we're trying to perform, but we have to practice the psychological and the mental aspect as well. And I know I've given you somewhat of a whirlwind tour through these different types of techniques today, but if you'd like to read more about them, you can take a look at my books where I talk about them extensively, and I'm happy to take questions. Thank you. Yes.
I was curious, you were talking about the importance of stepping away. And we often see that in our line of work, which is analytical question. And so when our team members get stuck, we would tell them to go wash the cat. If you're trying to wash the office cat, that distracts you enough. But one of the things that I read, though, is that while you're washing the cat, your mind is still working on the problem, like an operating system works in the background. Is that correct?
That's a great question. So the question was about stepping away. There was a cat involved as well. But the idea is that the question is there evidence that when you step away, you're actually maybe working on the problem in a different way, and that's why when you come back, you can see it. So I describe it as sort of you're getting rid of the dead ends, and you come back. And there's actually some really neat evidence for this. I'll give you a couple examples. First of all, anecdotally, the reason that you come up with that really great retort to your spouse, not during the argument, but 5 minutes after, is exactly from what you said. And there's actually amazing evidence that this is the case. Some of it comes from not humans, but actually birds. So scientists have been really interested in how birds learn very complex songs, which are somewhat similar to language and interesting and different in other ways. But researchers are able to do things in birds that they don't do in humans. And one thing is actually to record from individual neurons, brain cells, while birds, for example, are sleeping after they've learned, because we know actually that sleep is really important. It's another example of stepping away, and it's important for learning. And my colleagues actually at the University of Chicago have looked at birds learning songs during the day, and they show that after they sleep the next day, the song is more complex, even though they didn't practice anything else. And what they did is they recorded from individual neurons while the bird was sleeping, and they showed that as that bird was sleeping, they were actually, their brain was working on new complex iterations of the song. And so when they woke up, they actually knew it better. And that's true, we think, for how we do a lot of things, that you are often working on it on a subconscious level, and you're putting together connections that you might not otherwise do. And that's one reason why stepping away can be beneficial. Yeah.
In professional sports and perhaps music, we tend to slow things down because there's a difference between the neurons and the brain. Could you talk about how to practice performance?
So the question was about how to practice to perform, right? So oftentimes, when we're practicing or trying to learn or change things, we break things apart and we focus in on the detail. And there's certainly a time and a place to focus on these individual elements. But we also need to remember is that we have to practice under the kinds of conditions we're actually going to perform under and make sure that we're building it back up in that way. I think oftentimes, it's also an interesting idea about whether you can practice these safeguards. You hear students all the time saying, if I get messed up in the middle of a piano piece, I'm done. I can't get back there, right? So could you actually practice breaking in the middle of a piece so that you have an on-ramp to get back on to where you are? And I think we often don't think about that kind of thing. Yes?
Hi, thanks very much for your talk. This is beneficial to me on a lot of levels, but my question relates to sometimes people, before they perform this stressful task, they get so nervous that they have a curbed appetite, they might get sick. Why does that happen, and how can you sort of prevent that from happening?
Yeah, I mean, it's an interesting question. So the question is about what happens in our body in these stressful situations. So sometimes you don't want to eat, or you have these really extreme physiological signs, and there's individual differences. We have differences in how we feel in these sorts of situations. I think what I would suggest, and from the work out there, is that rather than focusing on how to make ourselves eat, which might not be a good thing in that moment, we should think about what those reactions in our body mean. We know that so it's really oftentimes about our body getting ready for whatever we're going to do. In fact, if we didn't have sweaty palms or if we didn't have a beating heart in these situations, we'd be dead, right? And so being able to reappraise, to think differently about why we're having these reactions are not a sign that we're about to fall on our face. They're actually a sign that we're up and ready and focused. Maybe a good way to turn some of what you're feeling into a net positive than a net negative. And it goes back to the study I talked about towards the end, where we actually can, if we can get people to reappraise, to think differently about these physiological states, they actually perform better. Yeah.
Did you come across anything in research in regards to age when you're studying first graders, 8-year-olds to 80-year-olds in their brain, and how they react differently in different situations, or the techniques that one might use if they are the 8 or the 80-year-old?
It's a great question. So the question was, do people at 8 and 80 look different in terms of how they're choking? And I don't have a good answer to that. One thing that we have been asking is, we know this writing technique can be really beneficial, but we also know that first graders aren't proficient yet in writing. So what about drawing? Does drawing do the same sort of thing to get people to get their thoughts out? And we don't actually have a good answer to that yet. My guess is that there's probably some similarities and some differences. I think it was actually surprising for us to find that first graders even had anxiety about doing math. So oftentimes people thought that for many years that this anxiety didn't form until middle school, when math maybe got harder. But we now know that there's a range of attitudes about math when students are in formal schooling, and part of that can be linked to their teachers. And actually, part of that is linked to their parents as well, which is something I didn't talk about today. But how we approach and deal with our kids sends them a signal about whether or not they should be fearful of a subject. And it doesn't even have to be overtly, oh, I hate math and that's okay. It can just be something as simple as, oh, it's okay that you're not good at math, I'm not good at it either, or I'm not a math person, which sends a signal about how stressed or comfortable students should be with this particular subject. Yeah.
When you talked about the Canadian athletes doing the reframing exercise, and then you said once they look back at that older video, they were feeling better about it. I'm just curious to know, how do these athletes who have learned the reframing perform the next time they face a situation?
Yeah, so Team Canada certainly thinks that they're doing better, and they have some new work showing that this actually improves their performance, or they're less likely to choke in future situations. I think that the jury's still out. We'll have to see what happens, but they're using this reframing technique as a way not only to change how they feel about it, but actually how they perform in those future situations. And there's evidence from other areas that that happens as well. Yeah.
It was really fascinating talk. So you were talking about how some strategies for people as they're about to have an event that's stressful. Is there any evidence for certain kinds of cognitive activities that people do over long periods of time that improve their ability to handle stress? So I think about this as kind of described as more high frequency at the time, but maybe long-term cognitive activities.
It's an interesting question. So we've used, for example, the journaling as a sort of a one-time thing, but there's actually evidence that when freshmen, for example, go to college, that's a really stressful thing, and journaling over the course of a quarter can actually increase their ability to focus. We also know that there's evidence, and I talk about it in both of my books, for things like meditation actually affecting our ability to focus on what we want and get rid of what we don't. And also for spending time and being in natural environments. So it turns out that being in natural environments allow us to give that sort of focused extreme attention a break, something that's on when we have our phone, when we're trying to prevent ourselves from going to Starbucks for the 8th time for the day, when we're trying not to get run over by a car. Neuroscientists are saying, look what we've discovered. Of course, this has been known by Eastern traditions for centuries, but this idea of being in natural environments and actually having ability to focus more and afterwards has come up in recent years.
Don't you find that journaling is therapeutic, and it helps you under the stress? It helps you to calm you down and maybe focus better when you're going to do it.
Yeah, so we show it in students' performance. We show they perform better, and anecdotally, I think they say that it sort of just helped them put it away, right? It helps them focus in that way, but I think, our evidence is that it actually helped them do better on the test in this way, especially for those students who were really stressed about taking tests. And we've shown the same thing with students who are really anxious about doing math, that doing this journaling before they take a math test can help that anxiety not relate to their performance in the same way.
I have a question regarding, you had said that our posture, our body language is not only communicating to others, but to ourselves. I recently was exposed to something called power posing, and is there any of your science that corroborates with just how, I guess, our posture is communicating to us and perhaps changing the way we're reacting or thinking?
Yeah, so there's actually so we know that, and I think it's unequivocal, that this power posing can make us feel more powerful. There's a big debate in the literature right now whether it actually changes levels of hormones or affects our ability to take risks. The jury's still out, but there's good evidence that it does. Being in these more expansive, powerful postures makes us feel more confident. And we know that feeling confident is sort of the opposite of these neural alarm signals going off, and that can be really important. I think how it actually does that and how it relates to our performance is still something that's open to investigation.
With your journaling, in today's technological world, when they were journaling, were they doing handwritten or typing, or did it matter?
I think it's a great question. So we've shown that typing is okay as long as people can see what they're writing. So if you can't see it, if it goes off the screen or you don't have, we think that there's something important about being able to look at the writing and go back and re-see it. There is some interesting work that's come out lately, though, showing the benefits of handwriting, especially for students who are taking notes in class. So there's a great study that was done out of a group at UCLA where they actually looked at students taking notes in college classes, whether handwriting or typing, and they showed that those who took notes by handwriting actually remembered the information better. And the reason is that when you're typing, you can type so fast you don't have to pay attention to what you're doing. But when you're writing, you actually have to synthesize on the fly and make sense out of what you're doing, which is another way of getting the information in deeper. It's why highlighting, rather than actually taking notes, is not so great in terms of reading something, because you highlight it. I mean, how many of us have highlighted? We don't even read while we're highlighting, we just highlight. But it's the idea of the number of times we can get it down and process it deep that's really important. Yeah.
So, I was struck with your very first example of the Canadian swimmers, that what they were really, in a sense, told to do was that they could be active. They gave them a sense of agency and empowered them. And if that's a large part of what's behind it, does it actually matter what you do, as long as you're told you can do something?
In terms of like, as you're told, you can do it, go kind of thing?
No, but you said, for example, you said if you really want to disrupt somebody's performance, tell them to think about their elbow.
Right,
So,
which really works.
but would there be a range of positive things?
Yeah.
Not just one technique.
Of course, yeah, and I think, what I write about in my books is a toolbox of techniques. This is how I talk about it. But they're based on these underlying principles that we want to get people to, in the moment, focus on the outcome rather than the process. Or think, we even know that swing keywords or thoughts or thinking about one thing you're going to change, which all are a sense of agency in a way, can be helpful. So I think there's certainly a toolbox of techniques and not one size fits all, but the science gives us insight into what those might be.
Sometimes when a person is being interviewed on television, it's noticeable that their heart is fluttering and they're flushing in the breast area or the neck area. And then they talk for a little bit and then they start into a rhythm. And you can almost see that time when the brain engages.
When they calm down,
Opens
yeah.
up and then it starts to flow. Does the breath affect your thought process? Is more oxygen to the brain or a reset happening at that time?
That's a really interesting question. I mean, we know that controlled breathing can, in some meditative practices, can have effects and relates to how you focus your attention. But it would be interesting to know whether you can see sort of in time changes in what we're seeing on the outside with what's happening with their breathing or other aspects. And I don't have a good answer, but it's a fascinating idea. But it gets to this idea that we often have the knowledge and the ability, and it's that moment when we stop having those stressful thoughts or feelings, or we become a little bit less aware of everything going on, that leads to a better performance. All right. Oh, yes.
Fear. Is fear just an exaggeration of stress? What's happened?
Yeah, that I think, so the question was about being stressed out in a particular situation or feeling pressure, having a phobia or a fear of, say, spiders or something like that. And there's a lot of the same techniques that we've shown can actually be beneficial in both of those situations. I think, our anxiety, or even what we talk about as fear about math, it operates on a lot of the same evolutionarily ancient neural mechanisms that are involved in physical responses to pain, how we would behave in a stressful situation. Math is a relatively recent cultural invention, but I think it's really interesting that we've sort of duct taped it on to those things that we use to be fearful of the lion eating us or the spider biting us. Okay.
Let's take this opportunity to thank Dr. Bialich for a very
Thank you.